Hey everyone! Quick heads up, this video is for educational use only. Everything here is done in a legal, isolated lab using DVWA. Please keep it ethical. Never try these techniques on real websites without permission. Stay safe, and let's dive in. Now I'm opening Burp Suite. I select Temporary Project and start with the default settings. After starting Burp Suite, I'm opening DVWA in the browser. Now I'm logging in using the correct username and password provided for the lab. Once logged in, this is the DVWA dashboard. DVWA is an intentionally vulnerable application used only for learning and practice. From the menu, I'm selecting Brute Force. This section is designed to help understand how brute force attacks work, but only inside a legal, controlled lab environment. Do not try this on real websites without authorization. Now I'm showing the proxy settings on the Burp Suite dashboard. Here you can see the proxy listener, running on the default port. Now I'm turning Intercept on in Burp Suite. This allows Burp to pause requests so we can observe how the application communicates. I'm navigating to the brute force page in DVWA. Now I'm entering test login details. These are not real passwords. With Intercept on, the request is captured before it reaches the application. I'm switching back to Burp Suite to view the intercepted request. This helps us understand how login data is sent and handled by an application. Now you can see that whatever we entered on the web page appears inside the request as username and password parameters. This shows how user input is sent from the browser to the server. Now I'm sending this request to Burp Suite Intruder. Intruder is used to analyze how applications respond to different inputs. I'm selecting the password field as a test position, just to demonstrate how input points can be identified. Now I'm opening a sample password list for demonstration. These are test passwords only, used to show how people often reuse weak or common passwords in daily life. This helps us understand why password reuse is dangerous. Now I'm looking for a grep match to help identify responses. I switch back to the browser and check the error message shown for an invalid password. This message helps us understand how the application responds when incorrect input is provided. I copy that response text and paste it into grep match. Now I'm clicking on Start Attack to begin the test run. You can see the requests going through, and most of them are marked as failed responses. This shows that the application is rejecting incorrect input. Notice here, one response looks different from the others. That difference indicates how the application behaves when the input matches the expected value. Let's open that response and observe the details. Now let's look at the details of this response. Here you can see the username and password we entered. I'm switching to the Response tab. Notice the status code is 200 OK, which means the server accepted the request. You can also see the response page code, showing a successful flow. Now switching back to the browser, and here you can see that we're logged in. This entire demonstration is performed only inside a legal DVWA lab for educational and awareness purposes. How to protect from this? The first step is using a strong, unique password. Avoid common or reused passwords across websites. Next, always enable two-factor authentication. Even if a password is exposed, the account stays protected. Applications should also implement login rate limiting and account lockout to block repeated attempts. Finally, use generic error messages so attackers can't tell what went wrong. Security isn't about hacking, it's about preventing attacks. Learn these practices, stay safe online, and for more tips, subscribe to Cyber Alert Tech.